Hello everyone, welcome to Top Scholars, the smart learning app. Today in this lecture, we are going to discuss some of the very important questions from the chapter electricity. So if you are preparing for the board examinations of the year 2024 for the CBSE board, then this lecture is going to be quite important for you because we are going to discuss many questions that will help you in the preparation of this particular chapter. Okay, so now let's get into this lecture and let's see how many questions can be important for you and which questions can be important for you in this board examination preparation from this chapter. Okay, so moving on to the first question. So a simple question, let's start with a simple question. Define power and state its SI unit. This is for 1 mark. So it is very simple. Power is defined as the rate at which electric energy is dissipated or consumed in an electric circuit. And this is the formula for power, that is P is equal to VI, V is voltage, I is current, or it can be also written as I square R, and it is equal to V square upon R by just putting the Ohm's law in it. Okay, now we have to talk about the SI unit. So SI unit of power is watt, or we can call it watt. Okay, 1 watt is 1 joule per second. Okay, so this is the SI unit. Moving on to the next question. Here is the next question. Examine the VI graph, that is voltage current graph for a resistor as shown in the figure, and create a table listing the values of I in amperes that correspond to 4 distinct values of V in volts. Find the value of current for V equal to 10 volt. How can we determine the resistance of the resistor from this graph? So here is the graph. As we can see, this is V, this is I, that is current, and we can see some values of current and corresponding values of voltage are given here. Okay, so here is 1, 2, 3, 4, and this is 5, then 2, 4, 6, 8, isn't it? And this is 10. Moving on. So first over here we have to draw a table, right? So first thing is the graph is a straight line, right? So here is the table. So current, first of all, I in ampere, and then voltage V in volts. So the first value is 0, okay, then second value is 1, third value is 2, then 3, then 4. Now the corresponding value of voltage is 0, 2, 4, 6 and 8. Okay, so these are the values that we have obtained from the graph that is given here. Okay, this one is the graph, and over here from this graph we can see that since this line is a straight line, that means it's a linear response, okay, and linear relation between I and V. Therefore, for 5 amperes of current, we must have 10 volts of voltage. Okay, so next, hence the value of current for V equal to 10 volts has to be 5 amperes. Okay, now from Ohm's law, V is equal to IR, so R is equal to V upon I, right? So at any point on the graph, resistance is the ratio of values of V and I. Since the given graph is straight line, ohmic conductor, so the slope of graph will also give the resistance of the resistor. Okay, so from this graph also we can find out the resistance, because as we know that R is equal to V upon I, and the graph of V versus I, for this graph the slope will be nothing but the ratio of V upon I only, isn't it? So that's why if we calculate the slope of that particular graph, then we are going to get the resistance. Okay, so here it is, R is equal to 10 upon 5, because we know for 10 volt the current is 5 amperes. So therefore resistance is 2 ohms. Okay, moving on to the next question now. Draw the symbols of commonly used components in electric circuit diagrams for an electric cell, open plug key, wires crossing without connection, variable resistor, electric bulb and resistance. Okay, let's look at the solution. First, electric cell. So this is the symbol for the electric cell. Next, open plug key. So this is the open plug key. This is the symbol, and when it is closed, we have to put a dot here. Okay, wires crossing without connection. So this is the one wire, this is another wire, it is crossing without connection. So that's why this is the symbol. Okay, variable resistor. So variable resistor is represented by an arrow. Okay, this is the normal resistance and this is the variable resistor by putting a arrow. Okay, next is electric bulb. So electric bulb is indicated by such kind of a coil. Okay, because generally in a bulb we use such kind of a coil. Resistance, and this is the symbol for resistance, or we can say resistor. Okay, so here this is the symbol. Next question, why are metals good conductors of electricity while glass is a bad conductor of electricity? Give reason. So it is very simple. Metals exhibit excellent conductivity of electricity due to their abundance of free valence electrons, allowing for efficient electron flow. In contrast, glass lacks free electrons, rendering it a poor conductor of electricity. Therefore, metals are effective conductors while glass is characterized by its insulating properties when it comes to electrical conductivity. So, as we know, the metals, they have got good number of free electrons, okay, but glass or materials like glass, okay, they do not have free electrons. So that's why they are bad conductors of electricity, or we can call it insulators, while metals are good conductors of electricity. Okay, so moving on to the next question now. The resistance of a wire of 0.01 centimeter radius is 15 ohm. If the resistivity of the material of the wire is 50 into 10 to the power minus 8 ohm meter, find the length of the wire. Okay, so what is given first of all? So radius of the wire is given, that is 0.01 centimeter. Convert it to meter. So after converting to meter, we get 10 to the power minus 4. Then resistivity is also given. Then resistance is also given. Okay, now length of the wire, what is it? That is what we have to calculate over here. So these quantities are related by a equation, R is equal to rho L upon A. That means if we have a wire, okay, something like this, let's say a piece of a wire which has a cross sectional area A, length is L, okay, and it has a radius of small r, okay, and the material has a resistivity rho, then such a piece will have a resistance equal to rho L upon A. Okay, so this is the simple formula. Now what we will do is we will put the numbers. Okay, first of all, over here area is pi r square. As you can see, this is a circular cross sectional area, so it is the pi r squared. Okay, then what we will do is, here is the length. Okay, what we have done is we have just arranged this equation. So after arranging for L, we get R and A on one side divided by rho. So value of A is pi r squared. Okay, so let's put all the numbers, and after putting all the numbers, we get 0.942 meters. That means it's a approximately 94 centimeter, okay, wire. So L is equal to 94.2 centimeter, and that is our answer for this question. So this is the next question. Two lamps, one rated 100 watt at 220 volt, the other 80 watt at 220 volt, are connected in parallel to electric mains supply. Find the current drawn by the two lamps from the line if the supply voltage is 220 volt. Okay, let's find out. Since both the bulbs are connected in parallel to a 220 volt supply, the voltage across each bulb is 220 volt. Since they are parallel, right? It is given over here in the question itself that the connection is parallel, and we know in parallel connection the voltage across each component, that is each resistor or maybe bulb, is same. Okay, so here both of these bulbs will get same supply of voltage. Next, the current drawn by a lamp is equal to power rating divided by voltage, because we know power is equal to V into I, right? So therefore I is equal to P upon V. Okay, so this is the formula. Now, current drawn by the 100 watt lamp, first of all let's calculate. So I1 is equal to, so first one is 100 watt, so 100 divided by 220 and it will be 0.454. Next is current drawn by 80 watt lamp and it will be, I2 is power divided by voltage and it will be 0.363 amperes. Okay, so this is the answer. Now, we have to calculate the total current or the net current from the mains supply, and this is I1 plus I2 and it will be equal to, I is equal to 0.81 amperes. Okay, so this is going to be the answer. Moving on to the next question. Consider the following electric circuit. Over here, this is the circuit that is given. Here is R1, R2, R3, R4 and R5, and here we have got a battery. Okay, here is the ammeter and here is the key which is closed. Which two resistors are connected in series? Then which two resistors are connected in parallel? If every resistor is 2 ohm, what current will flow in the circuit? Okay, here is the answer. The given circuit can be simplified as follows. So, after simplifying the circuit, it looks like this. Okay, so here is the same thing, just that we have just rearranged the connection. Okay, so that same circuit looks like this one. So you can see over here that these two resistors are in parallel and these two are in series. Okay, now let's answer the questions. So here we can see R5 and R4 are connected in series. Then R2 and R3 are connected in parallel. Now it is given that all the resistors have the value 2 ohm. Potential difference is 5 volt. So what is the current? So we can calculate that. First of all, the resistor R1 is shorted and does not contribute to the equivalent resistance, right? Then the equivalent resistance of R2 and R3, that is R dash, is given by, since R2 and R3 are in parallel, so we can use this formula which is for parallel connection. Okay, so it will be R dash equal to 1 ohm. After solving this, we get 1 ohm. Okay, now R5, R dash and R4 are in series. So the net equivalent resistance in the circuit, that is R, is, okay, because it is in series, we have to add them. Okay, so after adding, we get 5 ohms. So net resistance is 5 ohm. So the current in the circuit is found using the Ohm's law, and it is I is equal to V upon R, and V is 5 volt, R is 5 ohms. So therefore current is 1 ampere, isn't it? So this is going to be the answer for this particular question. Moving on to the next question. A fuse wire melts at 5 ampere. If it is desired that the fuse wire of the same material melt at 10 ampere, should the new fuse wire be smaller or greater in radius than the previous one? Give reasons. So here the condition is very simple. The fuse wire initially which melts at 5 ampere. Now we want another fuse wire, okay, which should withstand about 10 amperes of current and it should melt at 10 amperes. So should it be smaller or greater in radius than the previous one? That is what we have to find out. So let's look at the situation. Let the resistance of the wire be R. Heat produced in the fuse at 5 ampere is, the formula is I square R, right? So it is H is equal to I square R T. The actual formula is H is equal to I square R T. This is the actual formula that is given here. H is equal to I square R T. Let's consider T equal to 1 second for simplicity. So we'll talk about the heat produced in 1 second for simplicity, and I square RT. So I is 5. So 5 square into R. Okay. So fuse melts at 5 square R joules of heat. Okay. So this much heat will be produced in 1 second and it melts at that particular heat. Okay. Now let the resistance of the new wire is R dash. Okay. So heat produced in 1 second is 10 square R dash, just like this one. Okay. Here it was 5 ampere, now it is 10 ampere. So it is 10 square R dash, new resistance is R dash. To prevent it from melting, okay, if we don't want it to melt, that means this must be equal to this, is it? Okay. Now, so here we can see R dash is proportional to R upon 4, okay. So R is proportional to 1 upon A, okay. So cross sectional area of new fuse wire is 4 times the first fuse, okay. Cross sectional area of new fuse wire is 4 times the first fuse. Now area is pi r square, hence the new radius doubles the old one, okay. Thus at 10 ampere the new fuse wire, which is the same in length and material, has a bigger radius than the old one. So here this says that for the wire to withstand about 10 amperes of current, we need a bigger wire in size or in radius, that is double, okay. So this is the answer. Moving on to the next question now. Why are alloys widely utilized in electrical heating devices? Give reason. So it is very simple. Alloys are commonly used in electrical heating devices due to the following reasons. One is alloys have higher resistivity than metals because the resistivity of an alloy is more than the resistivity of pure metal. Alloys do not get oxidized or burn readily or easily, okay. So as we know, alloys have a very high melting points, so that's why they do not burn easily, okay. So that's why generally alloys are widely used in electrical heating devices, okay. So these are 2 main reasons why alloys are used. Next question. If a person has 5 resistors, each of value 15 ohm, then the maximum resistance he can obtain by connecting them is what? So it is very simple. Maximum resistance can be obtained from a group of resistors by connecting them in series, right? So here we have to connect them in series, because as we know, in series all the resistors will add up, okay, but in parallel they do not add up directly. In fact, their reciprocals add up. So here it is, the total will be 75 ohms, okay. Next is, this is the next question. 3 resistors, 20 ohm, 15 ohms and 5 ohm are connected in parallel, okay. Find their equivalent resistance. Here is the solution. Here they are connected in parallel. So let R equivalent be their equivalent resistance, okay. So 1 upon R equivalent is equal to 1 upon R1, 1 upon R2 plus 1 upon R3, and if you put all the numbers, okay, finally what we get is 1 upon R equivalent is this 3 plus 4 plus 12 upon 60, okay. Then after we solve this, what we get is 19 upon 60, and if we just calculate this, it is 3.15. Okay, so this is going to be the answer for this particular question. Moving on to the next question now. Show how would you join 3 resistors, each of resistance 6 ohm, so that the equivalent resistance of the combination is 9 ohm. So we have got 3 resistors and the values are 6 ohm each. Now what we want is the combination should have 9 ohms. So how should we connect it? So here it is. The resistance of the series combination is higher than each of the resistances. A parallel combination of 2 6 ohm resistors is equivalent to 3 ohms, right? So that means if you connect 2 resistors out of these 3 in parallel, then their equivalent will be 3 ohms. Then we can obtain 9 ohm by coupling 3 ohm and 6 ohm in series. So to obtain 9 ohm, the combination is as shown in figure. Okay. So here is the figure which shows this particular configuration. Okay, 6 ohm, 6 ohm, this will give us 3 ohm, and 3 plus 6 we get 9. Okay, so in this way we get this number. Moving on to the next question now. Draw a schematic diagram of the circuit consisting of a battery of 3 cells of 4 volt each, a combination of 3 resistors of 10 ohm, 20 ohm and 30 ohm connected in parallel, a plug key and an ammeter, all connected in series. Use this circuit to find the value of the following. First, current through each resistor. Second, total current in the circuit. Third, total effective resistance of the circuit, for 4 marks. Okay, let's find out its answer. Here it is. So this is the situation, right? These are the 3 resistors connected in parallel. This is ammeter, this is plug key, and this is the battery. It is the combination of 3 cells, each of 4 volt. So total voltage is 12 volts over here. Now we have to find out few values like current. Okay, so first let's try to find out the current. So here is the circuit, and what is given? So voltage of the battery is 12 volt, it is given. Current through 10 ohm resistance. So here it is. First is 10 ohm resistor. Okay. So we will write it as I10 for 10 ohm resistor. So it is equal to V upon R. V is 12, R is 10. So as we can see here, this is a parallel combination. So in case of parallel combination, each resistor will get the same voltage, that is 12 volt. So that's why V is 12, R is 10. So it is 1.2. Similarly, current through 20 ohm resistors is going to be I20, V upon R, 12 upon 20, that is 0.6 amperes. Next is the current through 30 ohm resistance or resistor. Okay. So I30 is equal to V upon R, 12 upon 30 is equal to 0.4 ampere. Okay. Now we have to calculate the total current in the circuit. So I is equal to I10, I20 and I30. All these will be added because this same current is split in 3 directions, I10, I20, I30. So definitely the sum of these 3 must be equal to this I, according to the conservation of charge. So let's add these 3 numbers. I is equal to 1.2 plus 0.6 plus 0.4, and finally we get 2.2 ampere. The total resistance now we have to calculate. So 1 upon Rp, that is, since they are all parallel, that's why we have to use this formula. 1 upon Rp is equal to 1 upon 10 plus 1 upon 20 plus 1 upon 30, and it is equal to 11 by 60. So this is going to be the answer. So Rp is equal to, if we take the reciprocal, it will be 60 upon 11. So that is going to be the answer for this question. Okay, moving on to the next question now. State Ohm's law. Represented graphically in the given circuit diagram, calculate the effective resistance of the circuit, the current through each resistor. So here we have got 3 resistors. 2 ohm, 4 ohm and 6 ohms. And we can see there is a voltmeter connected across them, and it's a parallel combination. So definitely each one of these will get the same voltage of the battery, that is 6 volt. Here is a plug key which is closed, that means the current is flowing, and this is the ammeter for measuring the current. Okay, so now we have to calculate few things here. First we have to state the Ohm's law. Let's look at the solution now. So Ohm's law, it states that the current through a conductor between 2 points is directly proportional to the voltage across those 2 points and inversely proportional to the resistance between them. Okay, so this is the Ohm's law. So it can be written like this: V is equal to IR. Okay, and this is the graphical representation of the Ohm's law. This is potential difference and this is current, and here is a straight line indicating the directly proportionality between these two quantities. Okay, so this is the graphical representation. Now we have to find out few values like the total resistance. So here for the given circuit R1, R2 and R3 it is given, and V is also given as you can see in the circuit diagram. Okay, so here the total effective resistance of the circuit, that is R equivalent, is given by, okay, since it's a parallel combination, we can use this formula: 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3, and after putting the values what we get finally is 11 upon 12, and therefore R equivalent is 1.09 ohms. Okay, and then since potential difference across each resistor connected in parallel is so, okay, so therefore V1, V2, V3 is equal to 6 volt. Since it's a parallel combination, each resistor will get same voltage. Okay, now moving on, applying Ohm's law. Now here V1 is equal to I1 R1, so I1 is equal to V1 upon R1, right? So 6 upon 2 is 3 amperes. Then I2 is equal to V2 upon R2, and it is 6 upon 4, that is 1.5 amperes. And then I3 is equal to V3 upon R3, 6 upon 6 is 1 ampere. Okay, so this is going to be the current. Okay, next question is, write the mathematical expression for Joule's law of heating. Okay, so this is very simple. Joule's law of heating implies that heat produced in a resistor is directly proportional to the square of current or a given resistance. Okay, directly proportional to the resistance for a given current, directly proportional to the time for which the current flows through the resistor. So this is the equation, I squared RT. This is the heat produced. Okay, next question is, explain the use of electric fuse. What material is utilized for fuse wire and why? Okay, so an electric fuse prevents the flow of any excessively high electric current. It consists of a piece of wire made of a metal or an alloy of appropriate melting point. For example, aluminium, copper, iron, lead, etc. So such kinds of materials are utilized for electric fuse. Okay, the temperature of the fuse wire rises if a current greater than the designated value passes through the circuit. Fuse wire melts as a result, breaking the circuit. So basically the use of fuse wire is to prevent any kind of damage to the electrical appliances whenever there is a excess current flowing through the circuit. Okay, so as soon as there is a excess current, the fuse wire will melt, okay, due to the heating effect, and it will break down the circuit and it will prevent any kind of a damage to the electrical appliances. Okay, so this is the use of a fuse wire. So in this lecture we have seen many questions, we have solved many questions which are important from the point of view of your board examination. Okay, so if you are preparing for this board examination, this is a quite important lecture for you. Okay, so I hope everything that we have seen today is very much clear and very well understood. So thank you so much for watching, and all the very best for your upcoming examination. Thank you so much.